the function f and g are defined by this and this. They want to state the range of g. So the range for g, okay, we know that the g0, okay, number one, we have the g of 0. It will become the 0 square minus 1 over 2. Then that is negative 1 over 2. If we have the g of 1, it will become 1 square minus 1 over 2. Then it is 0. So if I continue the substitution, okay, or I use the table in the uh, calculator, we have table, then the function is x square minus 1. So we have the x square minus 1 over 2, start from 0 until 5. So you can see that the smallest value is negative 1 over 2. Then it will continue increase. Okay. So we know that the range for g is that the y is greater than or equal to negative 1 over 2. Okay. So x squared minus 1 over 2. So we have the x squared minus 1 over 2. So x squared minus 1 over 2, and for x than greater than equal to 0, so we have the x greater than or equal to 0. Then this is how the graph look like. Okay, so this will be the graph. So we know that the range for this g is greater than or equal to negative half. Number 2, explain why fg1 does not exist. So the g1, fg1, so we want to have the fg1. Okay, g1, okay, because 1 greater than or equal to 0, then this will be 1 square minus 1 over 2. It will be 0. Then we have the fg1, then it will become f0. Okay, this one does not exist. Why this one does not exist? Because the domain for fx, okay, the x must greater than or equal to 2 for the domain for f. But 0 is not greater than or equal to 2. Okay, therefore, fg1 does not exist. Okay, later we need to show that the gf is this. Okay, so the question wants us to find the composite function gfx. So that is the g x squared minus 2 over x. Then this will become the x squared minus 2 over x minus 1 over 2. So to simplify this one is easy. Okay, we multiply with x here and here. So this one, it will become the x squared minus 2 minus x over 2x. Then the gfx will become x squared over 2x minus 2 over 2x minus x over 2x. Okay, so we can cancel this and cancel this. And then we also can cancel here. Okay, so it will become x over 2 minus 2 over x minus 1 over 2. That is the 1 over 2x. This one is ax squared plus bx plus ca. Oh, sorry, something wrong here. X squared minus 2. So this one is the g. Oh, so this is the g. This is x squared. It must be square. So the step that I do, all I done here is wrong. So minus 2. So the g, they have the g x is x squared minus 1 over 2. So this one have a square here. Okay, because we have the g, this will be this square minus 1 over 2. Okay, so it will become the x power 4 minus 4x squared plus 4 over x squared minus 1 and the whole thing over 2. So what I do here is I multiply with the x squared and the x squared here. Then it will become x power 4 minus 4x squared plus 4 minus x squared and the whole thing divided by the 2x squared. So it will become x power 4 minus 5x squared plus 4 and the whole thing divided by 2x squared. Okay. Okay. So we have this divided by this divided by this, and this divided by this. Then it will become 1 over 2 x squared minus 5 over 2 plus 2 over x squared. Okay, so this will be the answer. Okay. Uh, or I do actually this one over here. So this one is actually the uh, x power 4 over 2x squared minus 5x squared over 2x squared plus 4 over 2x squared. So we cancel this, cancel, and cancel. So it will become 1 over 2x squared minus 5 over 2 plus 2 over x squared. Okay, so for D, number 4, domain for GF. So domain for GF, okay, so GF, domain for GF, the F, x squared cannot be 0, okay, for this one, because we know that for gx greater than or equal to 0, then the range will be greater than or equal to negative half. So the gx, the range for g is actually the y greater than or equal to negative half. So when we have the fgx, then the inside here is greater than negative 1 over half. And for the f is greater than equal to 2. So we have the negative half and 2. So both is greater than. So the value for x that satisfies both is the x greater than or equal to 2. So this is number 4. So after that, they want us to show that the F inverse is this one. Okay. So for F inverse, okay. So F inverse. So before we find the F inverse, so to find the F inverse, like what I said, we will start with the sentence. Okay. Let Fy equal to x, then F inverse x equal to 1. Then we have the y squared minus 2 over y equal to x, y squared minus 2 equal to xy. Then we have the y squared minus xy equal to 2. Okay, then, oh, no. So we will have the this one I move in front. So minus 2 equal to 3, 0. So you imagine that this is a quadratic equation. So this is a quadratic equation. So for this quadratic equation with the unknown is y, then the a is 1, b is negative x, c is negative 2. Then we will have the y negative x plus minus square root b square minus 4ac. Negative x square minus 4, 1, negative 2 divided by 2a, 2, 1. So it will become x plus minus square root of x square plus 8 over 2. Okay, but we know that the fx is greater than equal to 2, then we take the positive side on it. So the x greater than equal to 2, so we take the positive side on it. So the f inverse of x will become the x plus square root x squared plus 8 over 2. Okay, so 8x squared plus 8 over 2. Yes, I'm using the formula here. So the formula is x equal to negative b plus minus square root b squared minus 4ac. Okay, so this is the equation. Okay.